So what we're going to start out with today is continuing our comparison of Java streams with other entities. And the entity that we're going to focus on here is Java collections. So I'm going to talk about how Java collections compare and contrast with Java streams. And it turns out that they're actually very synergistic and they work together quite nicely. And I'll also give you some examples to show you how to program with Java collections and Java streams, which will also illustrate the ways in which they compare and contrast and can complement each other. So first and foremost, Java collections are different from Java streams. This is a Java collection, such as the ArrayList. As you can see here, it's going to contain a contiguously allocated chunk of memory, which stores the elements in the list, which of course are generic, so they're elements of type T. And all these things are references to the elements. That's the way things work under the hood in Java collections, unlike, say, C++ collections, or containers, which have a different format, more value-based than reference-based. On the right-hand side, we see a classical Java stream, where you've got a bunch of aggregate operations that are connected together in a pipeline to transform and or filter flows of data through the stream. So what is a Java collection? It's an in-memory data structure that can store, retrieve, and manipulate groups of elements, such as an array list, or a HashMap, or a TreeSet, or a linked list. There's a whole slew of different collections that exist in Java. You can sort of think about a collection as something like the contents on a DVD. It's not a perfect analogy, as we'll talk about later, but the basic idea is that the information is stored someplace, and you can read and write to the contents in the CD. Usually read from, of course, in a DVD, but you can also write to it if you have a writable DVD. In contrast, a Java stream is a fixed-size pipeline that can process elements on demand. And so you can manipulate these elements that are obtained from various data sources, such as a collection, without the need to iterate over them explicitly. They're iterated over implicitly, as we'll talk about here in just a moment. So you can kind of think about a stream as being somewhat analogous to the flow of elements in a video stream. In other words, the content is processed as it flows through the stream. Now, these analogies are not perfect. Collections generally are not persistent, and streams are generally not infinite, but it kind of gives you a way of thinking about the difference. One's about flows of data that could be processed and transformed in some way or filtered. The other is about collections of things that can be read and written to in various ways. Now, what's interesting about all this, of course, is the synergy between collections and streams. So there's a bunch of factory methods that can be used to create streams from collections or convert collections into streams. The two of the most popular ones we've talked about are stream and parallel stream. There's a slew of other ones, but these are the ones we're going to focus on here. And they take a collection and turn it into some kind of stream, either sequential or parallel. And we'll see that every collection in Java comes pre-baked with factory methods that make streams. Conversely, there's a way to take a stream and turn it back into a collection by using the collect method. So let's talk about some examples of collections and streams in Java. So here's a simple example which you can get at the EX41 project in my Java 8 folder in my Live Lessons GitHub repository that demonstrates manipulating data with a Java collection and also a Java stream. So we'll start out with a collection first. So this example demonstrates what's called external iteration, where the iteration is taking place outside of the collection. In this case, it's using an index-based for loop. Not necessarily the best way to do things, but that's an example of external iteration for sure. And you can see here that we create ourselves an array of strings that have links to various entities on my old Washington University website. And over here, we make ourselves an array list of these elements. So we have a list of strings, of URLs. And then we're going to use a for-based loop, an index-based for loop. And for each element in there, if it contains this suffix, or rather this substring, we're going to go ahead and remove that. And if it doesn't contain that, we're going to ignore it and skip over it. If it does contain that substring, we're going to go ahead and replace it with my Vanderbilt URL instead. The downside, of course, with doing things this way is that external iteration can be a bit more tedious and error-prone to write, to read, and to optimize. In particular, it's easy to get off by 1 errors or off by n errors when you do index-based for loops, so you have to be careful of that. Second problem is it's difficult to convert this automatically into a parallel program without a lot of surgery on your part, very low-level programming. So let's take a look at how we can fix this by using a stream. Same basic idea. We want to be able to take this list of strings, convert it into a stream, and then we're going to filter out anything. We're going to ignore anything that doesn't contain the cse.wustel substring, and then we're going to replace the stuff that makes it through the filter. So we replace the cse.wustel with dre.vanderbilt, and then we go ahead and collect the results up into a list. And of course, nowadays, if you're using more modern versions of Java, you can just say toList rather than collect toList. And that will allow you to be able to convert the stream back into a collection. So the way to read this is we implicitly iterate through a pipeline of elements from a collection source. We filter and transform each value, and we create a collection as the result. You can also trivially change this. So instead of doing strings, you can go and do URLs just by putting in another transforming intermediate operation, in this case map, which is going to convert the strings into URLs and also handle the wacky checked exceptions by using the rethrow function adapter, which is a nice form of exception laundering, as it's called. And of course, the other nice thing here is it's trivial to convert the sequential stream into a parallel stream. Now, in this case, using a parallel stream is wildly overkill for this example because we've only got 3 elements in our list, in our array. But you get the point. You could easily generalize this if you had a lot more elements that you had to deal with. One thing to note is that, like iterators, elements in a stream can only be visited once. So if you want to do this again, you can't start with the stream you've already visited. You have to start over again from the beginning. So that's the end of comparing and contrasting Java streams with Java collections.